All right, so this is going to be a video that basically is a conceptual breakdown of what improper integrals are, and I listed some important points right here about what makes an improper integral an improper integral. So the first thing is, it says right here, integrals are based on limits. That should be a review. Integrals are based on, especially definite integrals, are based on limits in the fact that when you're trying to figure out the area underneath a curve, you are essentially finding shapes. Let's just say a rectangle that's infinitely thin, so its width is infinitely it's approaching zero basically. You need limits to figure out integrals just in general to figure out that area. Improper integrals are basically applying limits to the endpoints of the intervals of integration. So that's what it says in the orange right here. Okay, it says applying limits to the endpoints of the intervals of integration. And the endpoints that I'm referencing are when you have an integral and you're going from A to B, you're basically using limits on this A and this B. And we're going to show you the forms that it takes. So that's another key aspect of improper integrals is integrals are based on limits, but if you apply limits in a different context for a different part of the integral, then you get an improper integral. Improper integrals have the following form. If you notice in green and this blue, this is the different forms that improper integrals can take. If you have an endpoint or endpoints, it could be both of them. In this case, it's just one of them for each of these, but you could have one that's going from negative infinity to infinity. These ones just go one or the other here for the green, but it says the endpoint or endpoints are approaching positive or negative infinity. This first one right here, it is B approaching infinity, so we have this right here, the endpoint going to infinity for that. This other one, we have A going to negative infinity. You could have one where it's going from negative infinity to infinity as well. You'll see those a little bit later. The other form of improper integrals, you can have it where it's unbounded within the interval of integration. And I'm going to show you an example to kind of make more sense of this, but we want to think of this, the green, as more thinking with horizontal asymptotes. The blue would be vertical asymptotes of when it's happening. Okay, just to kind of tie it to something you do know already a little bit about. And it says the unbounded within the interval of integration. So sometimes, so we have this C value right here. If you remember, it's improper integrals involve applying limits to the endpoints. In this case, this C is the endpoint. It's approaching this B value from the left. So if you can imagine a graph, actually I'm going to show you examples in a little bit that kind of showcase this. And then this is the same thing, only with the bottom endpoints. You could have, again, both of them. This example just shows one or the other. So let's look at some examples. Okay, this first one right here in blue, I wrote right here, it says unbounded in the interval of integration. Okay, right here, if you look at the integrand, this thing right here, if you are approaching 0 to C is just any constant here, you would be dividing by 0 at the bottom here. Okay, so how would you find this height right here for whatever the function is? If you plug in C, it's going up forever here, so you wouldn't actually be able to find it. But what you could do is just get infinitesimally closer to C, and that's essentially what we do in this second part right here. You take the limit of B is approaching C, but from the left, so it's getting infinitesimally closer to that C, but never actually reaching it. Here's another example, only this time it's an infinite endpoint of integration. So if you look at this integral right here, we're going from 0 to infinity. So I kind of colored it in here in green. It's this spot right here. And you can imagine you're just coloring this in forever. You're not really supposed to write it this way for whatever reason. You're not supposed to put an infinity here. So you're actually supposed to write it this way with the limits as B approaches infinity, and then I put a B up here. And this one's actually a pretty good one to do because it comes up with a really interesting answer. But again, this is an improper integral because the infinite endpoint integration, even though this one ends up going down further, so this actually does converge to an answer. So again, it's pretty interesting. If you want, definitely try to work that one out on your own. And the last example I'm going to have actually includes both the infinite endpoint of integration and an unbounded interval of integration. So that means we're going from, if you notice right here, we're going from 0 to infinity. If you plug in 0 here, you're going to end up dividing by 0. You kind of see this asymptote right here at 0, the vertical asymptote. And then there's a horizontal asymptote since we're going to infinity right here. It's approaching 0. If you do the limit of this integrand right here, you can see that it goes to 0. And so what I had to do here, because it involves an infinite endpoint of integration and an unbounded interval of integration, I broke down the 0, since you can't plug in 0, so I made A approach 0 from the right. I'm going to 1 here. I just chose 1. It doesn't actually matter which one you choose as long as you don't choose 0 or anything that's less than 0. I chose 1. So it's basically going to do the area to like maybe here. Okay, so you're going to end up with this part for this first thing here. Okay, actually I should include this limit too for this whole thing right here. So what I just colored there represents this right here. And this other part goes from 1 to b, and b is going to infinity. So put a b up there, and that would represent the rest of this area over here. Okay, and you're just basically adding those two areas up. That this actually comes up with a really good, this problem actually comes up with a really interesting answer as well, so I definitely recommend trying to do this problem if you can. I'm not going to solve it for this video because this is just an introduction video of what improper integrals are all about from a conceptual standpoint. So that's improper integrals. If you have any questions about any of this video, let me know.